Hi everyone, welcome to the final tutorial of the Paleoclimate Day. As we've learned so far, paleoclimate proxies are really valuable tools for reconstructing past changes in climate. However, there are some limitations to proxies, some of which we've already discussed. For example, the spatial distribution of proxies is uneven and heavily biased to the northern hemisphere. Additionally, there are sometimes large age uncertainties associated with paleoclimate proxy records. However, there are also limitations associated with paleoclimate models. For example, models can't provide direct measurements of climate. One approach to overcoming the limitations of both paleoclimate proxies and models is data assimilation. Recall that on day 2 of the course, we learned how data assimilation can be used in contemporary climate analysis. Today, we'll focus on data assimilation applied to paleoclimate. Paleoclimate data assimilation combines information from climate models, high-resolution paleoclimate records, and instrumental data sets to create a more complete picture of past climate and its forcings. Proxies are useful because they provide direct climate measurements from a specific location. However, as we discussed, there are sometimes large age uncertainties associated with proxies, and they lack the spatial distribution that's needed to get a sense of global change. Models are useful because they can explore relationships within the climate system and assess climate forcings, but they don't provide direct measurements of climate variations. That's where data assimilation comes in. Data assimilation combines the strengths of both proxies and models to create reconstructions of climate variability that account for the diverse nature of proxy records while maintaining the physics-based simulations of climate models. Here's an example of results from a paleoclimate data assimilation. The figure on the left is showing the original model temperature time series in gray. This is compared to the reconstructed temperature assimilated with proxies, shown in blue. And you can see that there's a relative difference between the two, particularly from 12,000 years ago to 6,000 years ago. The map on the right is showing a spatial comparison of the data assimilation reconstruction compared to the original proxy records. In both scenarios, you can see the impact that data assimilation has on the overall reconstruction and the value of using data assimilation when assessing past climate change. In this tutorial, we'll look at paleoclimate reconstructions that were made with paleoclimate data assimilation. Specifically, we'll plot and analyze data from the last glacial maximum reanalysis, which contains temperature and delta 18O data for the past 24,000 years.